Hi friends, in this video we see um, gate problems related to maxima and minima. Right. So the first question is, minimum of the real valued function f of x is equal to x minus 1 whole power 2 by 3 occurs at x is equal to dash. Right. So I request you to see my video on maxima and minima, then only you will understand the procedure of the problem, right? So before watching this video, please refer my video on maxima and minima. So what they gave, f of x is equal to x minus 1 whole power 2 by 3, and they ask what is the minimum value of this function, where it occurs, right? So they ask the location of the minimum value, right? If you want to find the location of the minimum value, what you have to find, so you have to find f dash of x where slope is 0, right? So you have to find the point where slope is 0. So f dash of x will give slope, so I find that and make it as 0. So that location will give the minimum value. So what is f of x? This one, x minus 1 whole power 2 by 3. So f dash of x is equal to 2 by 3 x minus 1. 2 by 3 minus 1 is minus 1 by 3, and make f dash of x is equal to 0. This will give the location of the minimum. They are asking about only minimum, so it should have minimum only. So this indicates x minus 1 whole power minus 1 by 3 is equal to 0. This means x is equal to 1, right? So this is the location of x where the function becomes minimum. So the value of x, the minimum value of the function occurs at x is equal to 1, right? So the answer is x is equal to 1, option C. Next question, the maximum value of the function f of x is equal to x power 3 minus 9x squared plus 24x plus 5 in the interval. So they gave interval 1 to 6. So if they give interval, we have to find global maxima. They ask about maxima, so since interval is given, we have to find global maxima. Since interval 1 6, this is closed interval, right? Since closed interval is closed interval is given, right? We need to find global. Here they ask maximum, so we have to find a global maximum. So in order to find a global maxima, we need three data. So first one, we have to find where the maximum occurs. So first thing we have to find is where the slope is 0. That is f dash of x, and make it as equal to 0. Right? F dash of x is equal to 0. Sorry. F dash of x is equal to 0. This indicates f of x is x cubed minus 9x squared. F of x is x cubed minus 9x squared plus 24x plus 5. Right? First find what you call f dash of x. F dash of x will be 3x squared minus 18x plus 24, and make it equal to 0, because f dash of x will be equal to 0. 3 you remove, so this implies x squared minus 6x plus 8 is equal to 0. This implies x is equal to 2, 4. These 2 points are known as turning points, right? So at this point, the function may get maxima or minima. So these are all some important points. So this is the first thing we have to know. So next we have to find f double dash of x. F double dash of x will be equal to 2x minus 6. 2x minus 6. So if you want to find whether the maxima occurs at x is equal to 2 or x is equal to 4, or minima occurs at x is equal to 2 or x is equal to 4, we have to substitute this value here. So f double dash of 2 is giving 4 minus 6, that is minus 2. F double dash of 4 will give 2 into 4, 8, 8 minus 6, 2. Since it is less than 0, it gives maxima. Negative will give maxima. Since it is greater than 0, it will give minima. So what is that? they ask about maximum. So x is equal to 2 will give maxima. So we don't need to mind about x is equal to 4. Just discard it. So we need to consider only x is equal to 2. So first thing we have to find f dash of x, and from that we have to find the location of either maxima or minima by using x is equal to 2. So we don't know which is maxima, which is minima. So from this we are understanding. So x is equal to 2 gives maxima, x is equal to 4 gives minima. So if you want to know this procedure, please refer my video on maxima and minima. So I ignore x is equal to 4. So this is the one point I have to take into account. Next, what are the other point I have to take into account? This 1 and the 6. So these three are critical points. So x is equal to 2 is one important point, x is equal to 1 is another important point, x is equal to 6 is another important point. So substitute this value in f of x to find the value. Next procedure. So f of x, instead of x, I substitute x is equal to 1. So if you substitute x is equal to 1 here, what will happen? 1 minus 9 plus 24 plus 5. So 1 minus 9 plus 24 plus 5, that will give 21. Similarly, I substitute x is equal to 2, it will give x is equal to 2. When you substitute x is equal to 2, let us see what we are getting. If x is equal to 6, I substitute. When I substitute x is equal to 6, what I get is 216 minus 324 plus 144 plus 5, that is equal to 41. So f is equal to 1 is 21, f is equal to 6 is 41, means f is equal to 2 should lie between 21 and 41. So what they ask what is the maximum value. So out of these three value, which is maximum, that is called the maximum value. So x is equal to 6 will give maximum value of 41. This is the maximum value. This is the procedure we have to follow to solve the problem. So x is equal to 6, at x is equal to 6, this will be maximum value is 41. So when you are having a closed interval, we have to solve the problem like this. First, what we have to do, we have to take f dash of x and equate it to 0 and find points. So from this they ask what is they are asking, maxima or minima. So we have to find whether x is equal to 2 gives maxima or 4 gives maxima. To find that, what you have to do, f double dash of x you have to find and substitute these two value, and which is less than 0, which value gives less than 0, negative value, that is maxima. So that only we have to take, remaining point we can neglect. So 2 is important. Then we take another 2 points given in the problem 1, 6. So substitute all the value in the equation. Which one will give the maximum value? That value is the maximum value. Suppose if f is equal to 2 gives maximum value, what that gives is the maximum value. If they ask minimum, 21 is the minimum, right? So next problem we will see. It is also like a same problem. Here you see they ask minimum value and they give function and the interval also they give. Okay, we follow the same procedure. First what we did, f dash of x we have to find and equate it to 0. This implies what is f dash of x? F dash of x is nothing but 3x squared minus 6x minus 24 equated to 0. So simplify it, x squared minus 2x minus 8 is equal to 0. This will give x is equal to 4 and minus 2. Next what we did, we have to, so we don't know which is giving maximum. So for that we have to find the f double dash of x. That will give 2x minus 2. Right? So substitute f is equal to 4, it will give 8 minus 2, 6 less than greater than 0, positive. So it is minima. So x is equal to 4 gives minima. X is equal to minus 2 we substitute, minus 4, minus 2, minus 6. It is less than 0, so it gives maxima. What is the question? They ask minimum value. So we can neglect minus 2. Right? So neglect minus 2. But another thing, x is equal to 4 gives maxima. But here you see x is equal to 4 is out of the range. So this also we can neglect. If it lies in between the range, then only we have to take. So x is equal to 4 we neglect. So remaining two values only we have to find. So find f of minus 3 So if you find f of minus 3, what happens? Minus 27 plus 72. You substitute x is equal to minus 3. That's what f of minus 3 plus 72 plus 100. That gives 118. Similarly, you substitute next value f of plus 3. That will give 27 minus 27 minus 72 plus 100. That will give 28. So out of this, which is minimum value? Between this, 28 is the minimum value. So the minimum value is 28. Right? We follow the same procedure of the second problem. Okay. Next one, this is beautiful problem. We can solve it simply. At x is equal to 0, f of t is equal to sin t by t has dash. It is minimum or maximum or point of inflection or discontinuity. Here you see it is sin t by t. Sin t by t is nothing but a sinc function. Sinc will be like this. Right? We know it is sinc. So at 0, it has maximum. That's what the character of sinc. At infinity only it reaches 0. At minus infinity it reaches 0. So what they ask, at t is equal to 0, f sinc as maximum. See from the diagram. So sometimes you draw the diagram, functional diagram, and plot it, and from that you can find the answer like this. So at x is equal to 0, the function has maximum. Okay. Next. Consider the function x squared minus 4 whole squared where x is a real number. Then the function. Here they don't talk about what you call interval. So we have to find the local maxima or local minima. Right? If interval is given, we have to follow the procedure of problem number 2 and 3. So it is local maxima or minima. So okay, let us see f of x they have given x squared minus 4 whole squared. See, whenever you want to solve the problem, please refer the procedure from my video on maxima and minima. There I explain how to solve the problem. Right? This is this solution. So first what we have to do, we have to find f dash of x. So it is 2 into x squared minus 4 into 2x. That is 4x into x squared minus 4. First we have to find this and equate to 0. That we do regularly. So this implies x is equal to 0 plus 2 or minus 2. Next what we have to find? We have to find the second order differentiation, f dash of x. So 4x into x squared minus 4, if you differentiate, what you get is 4x into 2x UV model plus x squared minus 4 into 4. This will give 12x squared minus 16. Next we substitute this 0 we neglect, we don't use 0. So first what we do, f of f double dash of plus 2 we substitute. If we substitute 24 minus 12 into 4 minus 16, 48 minus 16, 32. Similarly we substitute f dash of minus 2, that is also giving 12 into 4, 48 minus 16, 32. So both are greater than 0. So surely this function has only minima. Right? How many minima? Both are minima. So 2 minima. So the function has only 2 minima. Fine. That's what simple problem. Okay. And next one is, here you see that f of x is equal to x into e power minus x, the maximum value of the function. They ask in the interval 0 to infinity. You see this is open interval. Whenever we are having open interval, we have to follow the procedure of problem number 5. Whenever we are having a closed interval, we have to follow the procedure of problem number 2 and 3. Right? Please remember. So open interval means local minima. Closed interval means global minima or maxima. So that we have to remember. So first what we have to do, as usual, we follow f of x is equal to x into e power minus x. First you find f dash of x. If we find x dash of x, x into minus e power minus x plus e power minus x into 1 UV formula. So that will give e power minus x into 1 minus x. That we have to equate to 0. This will give x is equal to 1. Right? So next what we have to do, we have to find the second order derivative, f double dash of x. That will give, what happens, e power minus x minus 1 plus 1 minus x into minus e UV formula. So it will give e power minus x x minus 2. So now I have to substitute this value here to check whether it is maxima or minima. F of f w dash of 1 e power minus 1, right, into minus 1. So surely it is less than 0. So 1 gives maximum. What is the maximum value? Substitute x is equal to 1 in the given f of x. F of x is nothing but x into e power minus x. So f of x is equal to x into e power minus x. To find that maxima, substitute f is equal to 1. 1 into e power minus 1, that is 1 by e. So the answer is option A. Right? Beautiful problem. Right. What is the question? The function is dash. Whether it is as only maxima or only minima or maxima and minima, like that they are asking. So there is no closed interval, so we have to find the local min or max, local minima or local maxima. The interval is opened. So as usual, we follow the procedure of problem number 5 and 6. First you find, as usual, if the first derivative you find 2 minus 2x equated to 0, this will give 2 minus 2x is equal to 0. This means x is equal to 1. Find f double dash of x, right, to check whether it is giving maxima or minima. So 2 minus 2x is minus 2. So whatever be the x value, f double dash of 1, it is minus 2. That is less than 0. Less than 0 means surely it will give maxima only. Whether it may be 1, 2 or 3, whatever it be, right? This is second order derivative is simply a constant of minus 2. So the function gives only maxima. So it has maxima, where for this problem it has maxima to x is equal to 1. Right? So I hope you understand all the problems. If you have any doubt, you can ask me in comment section. I will be clarifying everything. Right? Thank you.